My last session was a getting started with Solaris. So this one is sort of the evolution of that. Once you've got Solaris up and running, well, what good is it? Or what problems does it solve is how I've titled this presentation. So what I've tried to do is sort of come up with some common problems you may experience in the enterprise and talk about how Solaris has been designed to deal with those. So for example, managing your file systems. That can be a nightmare. I mean, you run out of disk space, how easy is it to add additional capacity. So we're going to look at how the ZFS file system and Solaris takes care of that. Your network. Now I should say the focus of the theme of this track is Solaris, not so much Open Solaris, if you're familiar with that. In most cases, everything I'm talking about today is available in Solaris with the exception of Project Crossbow. And I'll talk about that more when I get that, but that is something that's unique right now to Open Solaris. It will be in the next version of Solaris, but it made my demo nice, so I included it. And this will be mostly demo. The presentation is not too many slides. The other thing I want to talk about is taking advantage of today's machines. You're getting machines, Bill mentioned machines earlier today that'll have 512 virtual CPUs. Those are, like 8-socket machines with chips that have 8 cores and 8 threads per core or something like that, or some combination of that math. But you end up with a machine that has like 512 processors on it, a single box. What do you do with all that horsepower? How do you take advantage of that? And so I'm going to talk about the zones technology in Solaris, and then finally diagnosing your live system. So if you've got a system up and running, how do you observe what's happening? And so we're going to look at dtrace a little bit. Okay. So ZFS, the zettabyte file system. It's the phrase I like to hear, or what I like it, is the last file system you'll ever need. That's because it's a 128-bit file system. It has essentially an unlimited capacity as far as you're concerned. It'll hold 1 billion terabytes of data. Most people can comprehend how big a terabyte is, because maybe you have a disk in your house or a half a terabyte. Well, the ZFS file system has a capacity of 1 billion of those. That's kind of hard to wrap your head around, but I went to Wikipedia and I looked up a terabyte, and it said you could store, if every word ever uttered by a human was recorded in 16-bit audio in the history of man, it would take up like 48 terabytes, right? So 48 instances of ZFS could theoretically house a history of everything ever said in every language. More to the point, all digital data in existence today will not fit. A single terabyte could house all of that. So just to give you some perspective of how big that actually is. So the last file system you should ever need. But some other strong points to it is its file system integrity. So many of you may be familiar with running FCSK in Linux, or check disk or something like that in Windows. What's the? ScanDisk, is that the Windows one? Yeah, check disk, yeah. Anyhow, those commands are run because you've gotten your file system into some inconsistent state. You got a blue screen of death, or whatever, the power went out, and so maybe some file operation was happening, and it left your files in an unknown state, and so you have to run a system check. Well, every operation in ZFS is an atomic operation, which means it either exceeds or it doesn't succeed. There's a transaction involved, an atomic transaction, and so you never have to worry about the integrity of your data. Another nice feature is the snapshotting capability. So I'm going to show you, you can take pictures of your data as it exists at a certain point in time, very low overhead, and at any point in time roll back to that picture, get back to where you were. And then another really big feature is the integrated volume manager, or I've seen it referred to as there's no need to buy a volume manager. So things like creating, well, let's just go to the next slide. So it's just some history here. Traditionally, when the first file systems were created, I could actually have a third picture here that takes out the volume manager. You had a disk, a single disk, and then somebody wrote a file system to talk to that disk. And then somebody said, I want to do something cool like have multiple disks, and I want to stripe data across those disks, or I want to concatenate those disks. So rather than alter the file system, what was done is they created this thing called a volume manager. It's a third-party piece of software that makes the file system believe there's a single disk in play. Yet, underneath the covers, there could be all sorts of different RAID configurations, and it's the volume manager that's taking care of that for you. Okay, the first problem that introduces is there's a third party involved. So how can a file system ensure the integrity of your data when it's not even dealing with the bits on the disk directly? It's dealing with a volume manager. So it has some say in how valid your data is. And so that's one area where ZFS differs. So what we did instead is we decided to start from the ground up and chuck the volume manager and move the volume management directly into the file system. And we also introduced this concept of pooled storage. And this is really critical. Now, whenever you have additional disks that you need to, well, let me back up a bit. So when you want to work with ZFS, you have some amount of disks. Maybe it's just 1, maybe it's 10. But what you do is you assign those disks to a storage pool. And then from that pool, you create file systems. And the nice thing about this is those file systems all have access to the full capacity of the pool. And if you need additional space, you literally just add more disks to the pool. All the file systems can access that space. It's that easy. Not only is it that easy, but if there's a certain file system that you want to reserve so much space for, you can do that. Or if you want to put a quota on a certain file system so it can't use more than a gigabyte or something like that, you can do that as well. So a couple of commands you're going to use working with ZFS. The first one is zpool. It's for managing your pools. And so by the way, a lot of this is demo. The slides are going to be made available. So what I've tried to do is put the commands I'm going to use in my demos in the slides so you'll have a reference to them. But things you can do with zpool is view the pool, create the pool, add devices to the pool. So the first one I'm going to run is a list command to see my current configuration. So I currently have, this is an installed instance of Open Solaris, but ZFS works on Solaris as well. And I have a single pool that's called rpool, stands for the root pool. It's the pool that the operating system boots off of. You notice it's a 32 gigabit disk, of which 14% or 4.6 gigs is in use. I can run the status command, and I can see the device that makes up that pool, C7D0S0. And if you were in my last session, you'd have some idea of what that means exactly, but that's just how we label devices in the Solaris world. So I'm going to run the format command to see actually what other devices I have available to me. And I have 2 additional devices, C9T0D0 and C9T1D0. So using that information, I'm going to zpool create, and then I got to specify some sort of pool name. I'll call it demo. And then the device that I want in the pool. I think that's right. Now, if I wanted this to be a mirrored pool, I could specify mirror, and then I could specify the other device here, like so. And that would be mirrored. I'm not going to do that right now. I'm going to just leave it as a single disk pool. And hopefully we'll run that. OK, so now we have 2 pools available. The new pool, which I call demo. Notice, by the way, those disks I set up are just simple 1 gigabit disks that I made available. By the way, I'm doing this entire demo in a virtual machine in VirtualBox. I have a talk on VirtualBox tomorrow if you're interested more in about VirtualBox. So I set up a couple of the disks to do this demo. They're each 1 gigabit, and so you see my demo pool currently has 1 gigabit available. None of it is in use. Now, let's assume that it's all in use. I've run out of space. And this is sort of the nightmare we run into. It's like, man, I run out of space. How do I add more disk space to whatever I'm using? Well, with ZFS, it's as simple as zpool add, pool name, and then the device I'm adding to that pool. Now, when I list the pool, you see it has 2 gigabits in size available. Of course, it's all still 100% available. It's that easy to add space. So the other command you use with ZFS is, rightly enough, ZFS. And you're going to use this for managing your file systems. And this is a point of just a mental shift, is when you start thinking about file systems. Typically when I think of a file system, I think of a pretty heavyweight thing. Normally I have like 1 file system that I deal with. Well, with ZFS you can have hundreds of file systems on your operating system. And so that and alone kind of takes some getting used to think about a file system that way. And so we'll view the file systems on our machine, and we'll go ahead and create a new file system. All right, I'm going to start by running ZFS list to see what's on my machine right now. First of all, for you guys in the back, I'll use my cursor. There is the file systems are made up of what we call the data set name. Here's the demo one I just created. Notice I created the pool. It automatically created a file system for me, and it mounted it for me at demo. I didn't have to do anything else. Just by creating the pool, I get that. Now my root pool has these 8 or so file systems. Notice one thing I want you to notice is all of these in the root pool, everything from the first one down, have 26.2 gigabits available to them. Now, if you're used to partitioning a drive where you assign so much space to opt, so much space to var, and you're guessing, right? You're like, I don't know, I think I'm going to need this much, and you're never right, and you always get to a point where you underallocated one, overallocated another, and trying to shift that around is a big pain. So with ZFS, of course, I don't have to worry about that anymore. I have these different file systems, but they all share this pool of space that's available. Okay, so let's say I want to create a new file system. It's simply data set name and then file system name, like myFS. Just like that. You see it here in the list. It showed up. I can cd to that directory. There we go. I created it as a system administrator, so I switched into the system administrator role, so it'll just be easier to work with these commands. So anyhow, there's the file. I can start creating files. Now that's a simple file. Let's create something. Let's see. We'll make like a big file, 50 megs. Okay. Now there's a scrub command you can run on the pool. Basically, I'm just telling ZFS to just check itself and make sure all the data you present me is correct. So now when I run a ZFS list command, here's my demo file system. Notice it says it's using 50 megabits of space right now. That's the file I just created. Okay, so that's file system. The next thing we can do is take a picture of that file system, or what we call a snapshot. And this is one of the real powers of ZFS. Simply ZFS snapshot. And then what I'm going to snapshot is the data set name. So that was demo myFS. And then you use the @ symbol. And then I come up with any name that I want. What do I want to call this snapshot? Just some token. I can call it today. I've created a snapshot. Now that that's done, I can remove big file. I can make a new file. like that, whatever. And so I do some things. Time goes on. And then I realize, man, I want to get back to that snapshot I created. I accidentally deleted something that I need. This could be, well, in my case, it was 2 seconds ago. It could be 2 weeks ago. It doesn't matter. First of all, let me show you a ZFS list command to see what we have. And actually, I need to specify the zip list. There we go. I specified the type option so I could see the snapshot. So what you see in this list now is I have a snapshot that is referring to 50 megabytes of space and using 50 megabytes of space. So what I'm going to do is roll back to where I was. You see, that was lightning fast. And now I'm back to my big file, my 50 megabit big file, just like that. The bigger file I created is gone, it's history. I brought myself back to where the snapshot was. The other interesting thing is if I look at the file system list, notice the demo my file system at today is no longer using any space. That's why snapshots are so efficient. So even though I took a picture of the data, not until that data underneath the covers changes does the snapshot start consuming space. That's critical to understand. So you can feel free to take as many snapshots as you want. What else? Okay, we looked at the snapshots. Now what's the secret sauce here? What's really going on behind the scenes? How are we doing this magic? And it's really not that complicated. There's a hidden directory under the file system called .zfs. And then within there, there's a snapshot directory, and there you'll see a list of every named snapshot. So if I go to today and look at that, I see the big file is in there and the file 1 is in there that I created. That's really all there is to it underneath the covers, except for the fact that it's not really a separate instance of that file. It is, we don't, remember that file, that big file exists in my snapshot folder as well as in the demo myfs. There's not 2 copies of the file. It's a single copy. There's pointers to the same copy. Only when I start touching one copy do they start to differ. And it's at a block level. It's not at a file level. So it's also very efficient that way. Okay, so another critical thing you need to do is back up your data. Right, and so time has gone on, you've got a file system, so let's take this file system and we say we want to back it up. I can do a ZFS snapshot, or ZFS, what the heck was the command, sorry, send, that was it. And then I specify the data set I want to send, so this will be, let me clear this out. And then where do I want to send this data? I'm going to send it to my temp directory just for the purpose of this demo. Typically, you would send it to a mounted USB drive or a shared network server, something like that. You would back it up there. Call it whatever I want. It's just going to be a file. Thank you. MyFS. There we go. Now that I backed it up, I can we can destroy demo myfs. Now, it tells me, it says, Brian, you're trying to destroy the file system. Beware, there are snapshots and other things. There are children of this file system. And so I could either destroy them independently, or I can just use the R option to say, I don't care, blow all that stuff away. I must be in one of those. Let's see. Device busy. I don't know why that's not working. I've usually only seen that happen when I'm actually in the directory. Sorry?
You had a shoot from that directory.
What's that?
You have switched user to root from that directory. Within demo.
Ah, thank you. So you know what you get for that? A t-shirt. Which one of you said that? Here. Good. Yeah, that's right. Exactly, thank you. So what happened is I switched to root. I was in this directory underneath the covers. So we'll cd. Now we'll do a clear. MyFS-R. There we go, bingo, sorry about that. So now we can run a ZFS list. We see the my file system is completely gone. If I go to demo, there's nothing there. I've cleaned my system of that data. However, that data has been backed up. So at some future point in time, when I want that data, I can simply do a and I have to specify the pool. Demo, let me double check the syntax. Yeah, the pool name, and then, so I specify the pool name that I want to bring the data into. So this is interesting. This could even be a pool on another machine somewhere. It's a great way to move data around. So I'm specifying I want to bring it, in this case, back into the demo pool, and then the file, whatever you called it. Now what did I do? Oh, I forgot. There we go. And there's my FS, and there's my big file and file 1. It's back, just like that. Cloning is another cool feature, and this is really relevant, especially to things like developers. You have a snapshot of your source code, and you want to make a clone of it. You want to create a branch of it, something like that. And so I can take this data. So the data set name, again, demo myFS. And what I'm cloning is the snapshot. I've taken that snapshot. I want to create a clone of it. So where do I want that clone? We'll do demo myFS clone. I can call it whatever I want. Thank you. And now there's myFS clone. And it's got, and again, it was instantaneous. If we do a ZFS list, again, you see there's myFS. Now myFS clone is in the list. Notice it's not using any space. Again, it's a clone of that snapshot, and it will only start to consume space as it begins to differ from the file system it was cloned from. All right. What else do I have for you? Oh, and finally, I think properties. So why do I want to create all these file systems? What I tell people is generally with ZFS, where you would normally create a directory, consider creating a file system instead. And again, you kind of got to wrap your head around that. I mean, why a whole file system? Really, it seems kind of like overkill. But there's a lot of benefits to having a file system dedicated to something in particular. And so, for example, a real-life use case for me is, this is my, let's see here we go. This is my host machine. We're going to look at, everything I've been doing was in VirtualBox. This is actually my real machine now. Okay, you can see I have all these different file systems. I'm not going to go into detail, but one file system I do have is for VirtualBox. Let me, is that too small still? So one thing I've done is created a file system specifically for VirtualBox. And then I create snapshots of that file system. And so my VirtualBox environment is pretty complicated. I have a whole bunch of virtual machines, and I'm always doing different stuff in there. And plus, when I'm done giving this demo today, I want to roll back to a clean state. So what I have is a snapshot. You see my snapshots are called clean, like VBox clean. And when I'm done, I'll simply roll back. And if I were to give this presentation, in the next hour, I'd be good to go again. That's one way, personally, ZFS snapshots benefit me. Oh yeah, so in addition to snapshotting, there's also, each file system has its own set of properties. And so if we come here, So you can see this long list of properties that are available on the file system. And things like compression is off by default. I tell people, turn compression on your file systems. Today's computers are fast enough where they can compress and decompress data faster than it takes to write the uncompressed data. So not only do you end up saving disk space by turning on compression, but you actually improve performance. So it's what I call, definitely a win-win situation. But if you wanted to set a reservation of so much disk space or a quota where they could only use so much disk space, you could do all that through properties of the file system. Okay. All right, time slider is kind of a cool feature. Now, so what we've done is everything I've shown you has been at the command line. It's really intended for server-side type use. Well, we wanted to bring this to the desktop. And again, this is an Open Solaris only feature. I want to point that out. Everything I've showed you so far is available in Solaris 10. This particular feature, time slider, is only available in Open Solaris, and what we've done is put a desktop interface on top of ZFS, and so I can go to the Administer menu and enable time slider. We're just going to say OK. And now I'm just going to let some time pass. So what's going to happen is time slider is going to start taking snapshots of my file system automatically for me every 15 minutes. And then I'll be able to open the file browser and back up in time and see. And actually, let me show you again real time, or in real life. If we go to my desktop, here it is, and say, see, here's my desktop. I have various documents and icons on there. Well, if I go to the desktop folder, and there's this restore icon right on top. So I can click this, and now I've got this window that opens up right here that shows me I have 36 snapshots of my desktop consuming almost a gig of space, 754 megabits, dating back to February 1st, so roughly 2 months ago. And now I can go back in time. There's a bunch. You'll see as I go back in time, these are all today, then we get yesterday. They start to clean themselves up. So then we go back yesterday, Monday, and then we've got Monday, February 1st. And I go way back, and we can see what my desktop looked like. And I can look at it in list view. I can look at it in icon view. See, there's some picture of Steve Jobs that I definitely don't have on my desktop right now. But the list view is kind of cool because it shows me here in the restore information, like here it is, not present in latest version, identical to latest version, identical, not present, and so on and so forth. And so if I wanted this picture of Steve Jobs, for example, I could simply say, restore to desktop. And now I close this down, and there's Steve Jobs on my desktop. And yeah, kind of cool, huh? Not that I could care about Steve Jobs or anything, but. So the reason I have a picture, I'll tell you, the reason I have a picture of Steve Jobs on my desktop, it's a personal story, is I was somewhere without a belt on. I don't wear belts. And a friend of mine was saying, dude, why don't you wear a belt? That's so weird. And he loves Steve Jobs. And I saw this picture of Steve Jobs without a belt on. And so I saved it to email to him and say, look, your idol doesn't wear a belt. Stop, give me a hard time. That's why I have Steve Jobs on my desktop. Yes, yeah. So in Open Solaris, the only file system available, the default file system is ZFS. In Solaris 10, the default file system is UFS, or the Unix file system. But ZFS is available. So if you add new disks, it's just there. You don't have to enable anything. And so you can create a pool just like I did. Everything I did, you can do in Solaris 10 for sure.